Hi class. In this lecture here, we want to begin our study of conic sections by learning about what's called the ellipse. And you probably have heard this word before and have an idea of what the shape looks like. But what we're going to do is we're going to put mathematical equations to describe that conic section. All right, so what we're going to work through here. All right, we're going to talk about how you graph ellipses centered at the origin. We're going to talk about how you write equations of ellipses in what we call standard form. And then we're going to graph ellipses not centered at the origin. So I only have one example of each of these problems. And you're going to notice that as I go through the examples, it's not that the math here is really hard. It's just there's a lot of information, a lot of formulas, a lot of different variables. And so whenever I do these problems, I'm literally going to just write every single piece of information down. And I encourage you, when you go to try these problems, you follow the same method. Okay, I've got this piece of information. Let me make note of it. I've got this piece of information. Don't just let it all just be sitting in your head as you go through this. Okay, so what exactly is an ellipse here? So an ellipse is the set of all points P. Okay, so if you look over here, this is what an ellipse looks like. And you can see I have two different points P here, okay? But it's all, if you were to, there would be an infinite number of points all around this, okay? So it's a set of all points in a plane, the sum of whose distance from two fixed points we call F1 and F2 is constant. And I'll try to explain that, okay? Here's F1, here's F2. And I have a GIF here that's going to explain this as well, all right? These 2 points, F1 and F2, are called the foci, which is plural for focus, all right? And the midpoint of the segment connecting the foci is the center of the ellipse, okay? So this is the center. All right, let me explain this, the sum is constant part. Okay, so see this green line here? We'll call this distance from F1 to this point here D1, and from F2 to here D2. If you were to take their sum and compare it to any other point here, okay? Now this point here has a different distance from F1, we'll call D3. And this distance here from F2, we'll call D4. They would just be the same. Okay, so you can see here, it's the points, all these points here have the same sum of the distance between the two foci and that point that's going around the ellipse. Okay, that's what defines an ellipse. All right, so we've got some kind of understanding of what it is here. Let's start, talking about, mathematical equations to describe ellipses. Okay, so a little bit more information. So an ellipse can be elongated in any direction. So what you're seeing here is we have a horizontal and vertical elongation of ellipse, okay? This is a vertical elongation. You can see it's kind of stretched up high, all right? And this is a horizontal elongation. And I'm going to do one example of each of these, okay? The line through the foci intersects the ellipse at 2 points, all right, called the vertices. All right, singular, that's singular for vertex. The singular of that is vertex. So the line segment that joins the vertices is the major axis, okay? So what I'm hitting at here is on the elongated side, the endpoints here that I'm highlighting in red, these are called the vertexes, okay, the vertices, all right? And if you were to draw a line connecting the two vertexes, the vertices here, that would be the major axis, all right? And we're going to need these vertexes here and this concept of a major axis to help us sketch the graph, okay? So we have this line here, this major axis, really important to help us graph. Similarly, we have this, you can see here they have this thing called the minor axis, okay? So we've talked about this. The midpoint of the major axis is the center. You can see in both cases here. Now the line segments whose endpoints are on the ellipse that are perpendicular to the major axis at the center is called the minor axis. So what you can see here is I have two different points here, all right, on the other side of the center here. And when you draw this line to it here, that's going to be called the minor axis, okay? So this minor axis concept is also very important to graphing. And so here's what's going on. To graph these ellipses, what we're going to do is we're going to find these 4 points. Okay, so if you can find the endpoints of the major axis and the endpoints of the minor axis, you can just go right like that. Okay, so you're going to need to know the center and then the endpoints of the axes. Okay, both the major and minor here. All right. So it can be a little complex to find these. So that's what the goal is here. I'm going to help you figure out how to find these endpoints here, and then I'm going to help you show you how to graph from that. Okay, so the standard form of the equation of ellipse with center at the origin. Okay, so this is important here. This first example is going to be when it's centered at the origin. Okay, point 0, 0. All right. In major and minor axis of length, what we call 2a and 2b, okay? So what that means is to go from here to here is this length 2a, and to go from in this case here with the minor axis, from here to here, this length would be 2b, okay? And what you're going to notice here is when the major axis is going to be defined by this letter a, all right, and the minor axis is going to be defined by this letter b. Okay, so a squared is always going to have to be greater than b squared. All right, so this is the case here. This is where we have this horizontal elongation. Okay, this going back here, this horizontal elongation right here. What'll happen is you'll have x squared divided by a squared, okay, plus y squared divided by b squared is equal to 1. So notice how it's set equal to 1 in both of these formulas here, okay? So the major axis, okay, all right, in this case here is length 2a. So what this means is what's important. This will help you, this tip I'm going to give you will help you determine if you have a horizontal, or in this case you have the vertical elongation. The larger of the a and b is under the x squared. Now, if you have vertical elongation, the larger of the values is under y squared. So that's going to be important to help you notice, okay? And then once you do that, look, if it's centered at the origin, the vertices, okay, of the major axis, okay, so like this one over here, it'll be 0, a, 0, negative a. And then the minor axis, the endpoints of those 2 points that I talked about, is negative b, 0 and b, 0. Okay, so that's really important, right? Over here, we have our major axis here, all right? So our a is going to be negative a, 0, and my other point will be a, 0. And then for the minor axis here, the 2 endpoints that we're going to need here are going to be 0b and 0, negative b. And you can see here I have these other points here. These are this negative c, 0, and c, 0, and over here 0c and 0, negative c. These are the foci, okay? The foci. And there's a very simple formula for helping us find the foci, all right? So the vertices going back here, all right, the vertices on the major axis, a units from the center. The foci are on the major axis, c units for the center, okay? So for both equations, the way you're going to find the foci, you could have b squared is equal to a squared minus c squared, or equivalently, this is what we'll use to help us find foci, is c squared is equal to a squared minus b squared. Okay, so we use this formula to find foci. All right. Totally okay right now to be like, Matt, this is very confusing. It should be. All right. So what we're going to do is hopefully over the first example, all right, you can start to see some of these formulas get into get going, get into the groove of this. Okay. So here's what we want to do. We want to graph this ellipse, and we also want to locate the foci. All right. So here's the problem. I have 16x squared plus 9 squared plus 9y squared is equal to 144. So the first thing you're going to do is you're going to put in standard form By dividing the 144, okay, over. All right, because if you look back, our standard form is always equal to 1. All right, so I have 16x squared plus 9y squared is equal to 144. So I'm going to divide everything by 144. Now I'll just help simplify here. 16 goes into 144 9 times, so this is x squared over 9. Here this goes in 16 times, right? It's just the flip, is equal to 1. All right, now notice here, look, 9 and 16 are perfect squares. Notice here it's a squared over b squared. Okay, a squared over b squared. So let me write that in that form. So this is x squared over 3 squared plus y squared over 4 squared. All right, so look here, all right? Which one has the larger denominator? Okay, it's the 4 squared. So that is this case here. Okay, right here. Notice how the larger value, all right, is under the y squared here. Okay, because a squared is always greater than b squared. All right, so what that means is we have vertical elongation here. Okay, all right, so that means the major axis is on the vertical part of the ellipse. Okay, all right, so denominator is larger under the y squared. So vertical, or so major axis is vertical. Okay. So this is the information we then have. When it's like this, okay, that means it's centered at the origin. Okay, when you just have, x squared and y squared by itself in the numerators there. All right. So the center is 0, 0. And look, this value of 4 is my A, and this value of 3 is my B. Okay? So look, I can now find the endpoints of the major axis and the endpoints of the minor axis here. Okay? So let's find the vertices of the major axis. Look what it is. Okay, this is important. Look what it is. It's 0, comma A and 0, negative A. Well, look, I have A. So it's 0, comma negative A and 0, comma A. All right. So I have one at 0, comma negative 4, and I have another one at 0, comma 4. But now look, going back, I can also find the vertices of the minor axis. So it's negative B, comma 0 and B, comma 0. Okay. So 0, or excuse me. Sorry about that. It's negative B, comma 0 and B, comma 0. Almost made a little bit of a mistake there. Okay, so look, I have my B. So that's just minus 3, comma 0 and 3, comma 0. All right. So look, do you remember how I said you needed the 4 points to graph? Boom, 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 boom. But it did also ask you to locate the foci. All right, so just to have these extra points here. So look, the foci, because we said it was a vertical elongation here, the foci is going to be the point 0, comma C and 0, comma negative C. But what you have to do is you have to find C. And so this is where you find C. C squared is equal to A squared minus B squared. So C squared is equal to A squared, which is 4 squared, minus B squared, which is 3 squared. So c squared, this is 16 minus 9. So this is 7. So take the square root to solve here, and you get c is equal to 7. Square root of 7, excuse me. So my foci then are 0 comma the square root of 7 and 0 comma negative square root of 7. And that's roughly like 2.6, like 2.64, 2.65. All right, so now using this information, let me show you how you graph this. All right. Okay, so now we graph this. X squared over 9 plus y squared over 16 is equal to 1. And forgive me, I'm going to draw this freehand here, and then I have the better version here, but I'm going to draw this freehand so you can see the actual process. Okay, so it's centered at the origin here. Boom. So plot these points, 0 comma negative 4 and 0 comma 4. So 0 negative 4 is down here, and 0 4 is up here. Okay, and this right here is my major axis. Boom, boom, boom. Now the minor axis here goes from negative 3 comma 0 to 3 comma 0. So here's negative 3, 0. And here's 3, 0. Okay? So this is my minor axis. So then you're just going to draw the ellipse through it. And it looks like a circle because I'm drawing this freehand, but it's not really a circle, okay? You know, just not everything I did here is perfect, okay? Okay. And so look, you can see here, you know, I've also plotted the foci here in this graph here, but you can see how you do this, okay? So look, the hard part here, again, the hard part here is not like the math. Like, you know, there isn't much hard, like, out or anything beyond arithmetic here. It's what information do I have? I have my A, my B, and then how do I use these formula to help me here? All right, let's do one that's not centered at the origin, okay? All right, so here's the problem. And actually, let's go back, and I'm sorry. Before I do that, let's talk about let me give you some information and finding the equation of ellipse from its foci and vertices here, okay? All right, so it says find the standard form of an equation of an ellipse with foci, okay? So, and then I'll go to the one not centered at the origin. Sorry, I want to get this extra example in here. So foci, negative 2 comma 0 and 2 comma 0, and vertices at negative 3 comma 0 and 3 comma 0. All right, so what's going on here is this right here, they're telling you, okay, it's centered at the origin. Okay, so this is what we're going to need. We're going to need x squared over a squared, or it could be over b squared, we're not sure yet, plus y squared over b squared is equal to 1. Or we have to decide if it's x squared over b squared plus y squared over a squared is equal to 1. So here's what's going on. It's telling you that the vertices are occurring on the x-axis. So let's go back. And look, what that means here is we have this case right here, because they're saying when they tell you the vertices, they're telling you this, okay? Here and here. So it's going to be this case right here. Boom, 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 okay? So what they're telling you here right off the bat is they're telling you a is equal to 3. But what you need to find is you need to find b. Okay? So how do we do that? Well, look back here. We have this formula here. B squared is equal to a squared minus c squared. Well, look right here. When you get the foci, they're telling you c is equal to 2. So here we have b squared is equal to 3 squared minus, and then c squared here is 2 squared. So b squared is equal to, what do we have here? We have 9 minus 4 is 5. So b is going to be the square root of 5. All right, so now plug in. A is equal to 3, and b is equal to the square root of 5. So you have x squared over 3 squared plus y squared over the square root of 5 squared is equal to 1, which is just x squared over 9 plus y squared over 5 is equal to 1. Okay. So just a little bit of an extra example there. Sorry, I skipped ahead there. All right. So these last two examples here have now been centered at the origin. Okay. So what about when the ellipse is not centered at the origin? All right. So what's going on here is we're going to be talking about ellipses centered at, instead of 0, 0, hk. So h is the x coordinate, and k is the y coordinate here. All right, so again, you got to figure out right off the bat if if you have this horizontal elongation or the vertical elongation. Okay, and so basically everything is still the same. Everything is still the same. The only difference is you have, instead of just x squared, you have x minus h squared plus, and then in parentheses over a squared, plus, and then in parentheses y minus k squared over b squared is equal to 1. Or that's if you have horizontal elongation. Or if you have vertical elongation, you have x minus h squared divided by b squared plus y minus k squared over a squared is equal to 1. All right. And what you're going to notice here, okay, is that when you go to plot, for this case here, the major axis, you take the center and you shift it to find the vertices, a units to the left and then a units to the right. And then to find this point up here and here, it would be h comma, and now you're moving the k plus b, and then this one here would be h comma k minus b. All right. And then what you can see here, okay, because this one has a vertical elongation here, okay, from the center, this would be h comma k plus a, this would be h comma k minus a, and then over here, okay, the endpoints of the minor axis, okay, would be h plus b comma k, and over here it would be h minus b comma k. All right, crazy stuff going on here. All right, but let me give you some information here, and then we'll give this a shot to graph. All right, so let's sketch the graph of this. All right, I just want to sketch this ellipse. So this is x plus 1 squared over 9 plus y minus 2 squared over 4 is equal to 1. All right, so first off, you notice it has a plus in here, but all these equations have minuses. So let's just rewrite it first. So this is x minus 1 squared all over 3 squared plus, or then here this is just y minus 2 squared all over 2 squared is equal to 1. All right, look, This is my h, this is my k. So let's write down the information. So the center is the point -1, 2. Now, which one has the larger denominator? All right, it's under the x. So look, under the x right here. So this is going to be horizontal elongation. We're going to use this graph here. Okay. So this is my a, and b is equal to 2. All right. So then all you have to do, remember what I said. You got to plot the 4 points. Boom, 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 boom. So let's do the major axis stuff. So the endpoints of major axis. Okay, so look, it's h minus a comma k, and then h plus a comma k. And so that's why you're using all this stuff. Okay, this is my hk right here. So this is -1 minus 3 comma 2, and this is -1 plus 3 comma 2. So what is this point here? -1 minus 3 gets me -4 comma 2, and then -1 plus 3 gets me 2 comma 2. So look, I found the endpoints of the major axis. Boom, boom, boom. Now let's do the endpoints of the minor axis. So here, look, it's going to be h comma k minus b, and then h comma k plus b. So my h, this is good, so this just stays. It's -1 comma k, which is 2 minus 2. And then it's -1 k, which is 2 plus b, 2 plus 2. So this is -1 comma 0 and -1 comma 4. All right, plot the 4 points. Okay, and then from there you'll see, whoop, it's going to become really, really quick and easy to do. All right. Doing this by hand is not the easiest thing, and as you'll see on the next slide here, I have the perfect graph of it. But all right, so let's go back. Our center was -1 comma 2. So -1, 2. There's the center. Let's do the major axis. -4 comma 2 and 2 comma 2. -4, 2 and 2, 2. Now let's do the minor axis. -1, 0 and -1, 4. -1, 0. -1, 4 is up here. And look. Right there. That's exactly what it is. All right, so I know this, again, the math here, hopefully you see the math here is not too hard. It's all these different formulas and then, correctly applying them. But, if you have any questions, I'm always here to help. And, after you do a couple problems, you'll see the pattern. All right, class.